Hi guys. So this is Kairos week for myself and a lot of your classmates, and so I wanted to create a couple of videos that will get you moving on the new section, the new chapter. So we have about 6 weeks of school left, and we're going to split that up about 2 weeks and 2 weeks, or a bit more. And the next unit we're going to do is chapter 10, exponents and logs, one of my favorite topics. So before we dig deep into logs and exponents, I thought it would be worthwhile to just review some of the exponent rules and make sure that you remember those exponent rules. So I'm just going to dive into it because you've had all these before. It's just a matter of remembering them and reviewing them. Things like if you're multiplying two terms that have the same base, you can add the exponents. Similarly with division, if you're dividing with the same base, you can subtract the exponents. Again, I know you've had all these before. Things like if you have one base raised to two different exponents, or the same exponent for that matter, you can multiply those exponents together. Two bases raised to an exponent. That exponent gets applied to both of the bases. Same goes with division. That exponent gets applied to both the numerator and the denominator. And then the last one being that if you have a base raised to a fractional exponent, the denominator of that fraction becomes the root, and the numerator of the fraction stays an exponent. And that exponent can be either inside the radical or outside the radical. And that's completely up to you, just depending on the application of the problem. So I know you've had all these before, just a quick review of the different exponent laws. And what we're going to do to practice with these is two things. First, we're going to simplify expressions, and we're also going to solve equations. So first, let's hit the simplifying piece. I'm going to move. No, I'm not. This is the division. There we go. So that looks like a pretty complicated expression there. The key to all of these exponent rules up here is that the bases are the same. Like with this guy, the bases are all the same. So what we want to do with our problem here is we want to try to rewrite this so that the bases are the same. So just looking at the numerator, I have a base of 4 and 8. I can rewrite both of those numbers with a base of 2. So 4 becomes 2 squared. 8 becomes 2 to the third power. Then in the denominator, same thing. I can rewrite 16 with a base of 2. So that would be 2 to the fourth power. Now, before I do anything else, I'm just going to clean up some of these exponents. Like this exponent can be simplified a bit, and this exponent can be simplified a bit. So we'll rewrite my first part here, and then the 3's cancel, and we have 2 to the rad 2 power. Half of 4 is, of course, 2, so that'd be -2. And now I can apply those exponent laws. So because the bases are the same, I can add the exponents. So this would be 2 rad 2 plus 1 rad 2 is 3 rad 2. And on the bottom, I can write an expression that shows that I'm adding, though I can't really add them because, of course, one of them is a radical number and one of them is not. So I can't really combine those. Division problem, again, with the same bases, which means I can subtract my exponents. And remember, you're subtracting this entire exponent, so I'm going to put that in parentheses to show that. Now I'll distribute the negative through. Combine my like terms. And I know that solution looks still a little messy with that 2 rad 2 plus 2 exponent. It's kind of gross looking, but I think we can all agree that that answer is more simplified than the original problem was. So I guess that's a bonus. Let's look at the next one. Again, we're simplifying. And I'm going to change that b because it looks a lot like a 6. We'll change it to an x. So I have the square root of x raised to the radical 6, and then that raised to the radical 6. So applying this rule right here, I can multiply those exponents together. That gets me rad x. So those exponents can be multiplied, and rad 6 times rad 6 is just 6. And then, this is the square root. So using that property that we mentioned up here backwards, kind of from there to there, that root goes in the denominator of the fraction in the exponent. So this is kind of like x to the 6/2 power, which is x to the third. So that whole thing just becomes x to the third, much simpler than it started. Well, we can also use those exponent rules to solve equations. So let's look at a couple of solving problems. As always, when you're solving, you want to get x alone. So to get x alone, I need to take care of this exponent first. And I can choose to write it as a root, but I feel like that's going to just slop it up a lot. So instead, let me rewrite the problem. And what I'm going to do is I'm going to raise both sides. I'm going to raise both sides of this equation to the, how about to the third power? Even better, how about to the 3/2 power? And I'm choosing to do that because 2/3 times 3/2 is 1. So that gets rid of that whole exponent on the left side of the equation. Now be really careful about this because ultimately what you've just done on the right side is you've square rooted both sides. Having that 2 in the denominator of the exponent is like a square root. And when you square root something, you've got to put that plus or minus in front. We'll deal with that 3/2 in a little bit. We'll simplify that and clean that up in a bit. Let's just keep solving for now. So I'm going to add 10 to both sides. So that gets me 10 plus or minus 2 to the 3/2 power. And then divide both sides by 3. So that's x equals 10 plus or minus 2 to the 3/2 power over 3. And then we can just clean that up a little bit because that 3/2 power can be simplified a bit. Rewriting that as a root, that would be the square root of 2 to the 3rd power. 2 to the 3rd power is 8. And the square root of 8 is 2 rad 2. And there we have it. Let's look at this next one. Same thing, I'm going to rewrite the problem and raise both sides to an exponent that will help me get rid of that 3/2. It's the same 3/2 as before. So I'm going to raise both sides of this to the 2/3. Three over 2 times 2/3 gives me an exponent of 1. And now we have 27 to the 2/3 power. Now I recognize that this is different from the last one because the last equation was linear once I got rid of the exponent, but this equation is quadratic once I got rid of the exponent 3/2. So I need to solve this as a quadratic, which means I really need to take this 27 to the 2/3 power and move it to the left side and solve it. So I kind of want to simplify this right now. This would be the cube root of 27 squared. Cube root of 27 is 3. 3 squared is 9. And now I can move that 9 over. Factor this. And solve it. Now, just one thing that I want to mention and make sure that you're aware of is when you are working with especially problems like this one, where you cube rooting, square rooting, cubing, squaring, your exponents are flying all over the place, and then you have a quadratic you have to solve, sometimes you'll end up with answers that are called extraneous solutions. These are problems that mathematically look like they should be solutions, but when you go to check them, they're not. They don't make the equation true. So it's really worth it to just take a couple minutes to check your answers and make sure that both of the answers that you get are actual solutions to the equation and that nothing is extraneous. All right, guys, so now it's time for you to practice. In your book on page 402, I want you to try out numbers 5 to 24. Those are all problems that will help you get some practice with both simplifying and solving and reminding yourself about those exponent rules from up above. All right, thanks so much, guys. Have a great day.